Alright, in this chapter we're going to talk about probably the most important topic in all of finance, and that's time value of money. It's no stretch actually to say that if you understand time value of money really well, then there's a whole lot of other things in finance that just make sense very easily. But if you don't understand it, then there are going to be a whole lot of other things in finance that just do not make sense. So if I could only teach you one chapter, or if you were only going to really understand one chapter out of this entire course, this would be it. So please pay special attention to it. So without further ado, let's go ahead and get started with some of the basics. First, I want to introduce one of the tools that we're going to use a lot as we solve time value of money problems, and that is a timeline. Timelines are good for visualizing cash flows that happen at different points in time. So for example, here you have a 3-period timeline. Period 0 represents today, 1 represents 1 period from today, so perhaps a year, and 2 would represent 2 periods from today, likely 2 years, and of course 3 would be 3 years, and so on. And then of course we can list the cash flows that occur at the different points in time, as well as the interest rate that applies over the length of the timeline. So as an example, let's say that there was a bond or something like that that promised to pay us $100 2 years from now. Well, this would be a way to visualize that on a timeline, the $100 to be received in 2 years, and then we might logically be asking questions like, how much would be reasonable to pay for that bond today given market conditions? We'll talk about that soon. And then you might have another type of security that doesn't just pay you a one-time cash flow. Maybe it pays you, for example, $100 a year for 3 consecutive years. That is, at the end of each of 3 years. How much would that be worth? Well, the timeline helps us visualize the cash flows, and then in a later part of this chapter we'll discuss how to actually find the value of a security that pays something like that. Another possibility for an example of a timeline would be something like this, where you have an uneven cash flow stream. Let's say, for example, that your company was considering a project that would require an initial investment of $50,000, so that would be a cash outflow up front, but the project would pay you back $100,000 after 1 year, followed by $75,000 after 2 years, followed by $50,000 after 3 years. And this timeline would help you visualize those cash flows so that you could decide whether to go ahead with that project, and if so, how much it's worth to your firm. Alright, now we're going to begin with what is actually a very straightforward, very simple problem, and you've probably had this at some point in another business class. If so, that's fine, but bear with me because we are going to get to some more interesting stuff later on. But let's start simple and then we'll build up to other stuff. Okay, so the problem here is, suppose you deposit $100 into an account today, and over the course of the next 3 years you're just going to leave it there. You're not going to take any money out of that account. You're not going to add any more money to the account. And during that 3 years you're going to earn a rate of return of 10% per year. So what I want to know is, what's the future value? In other words, how much money is going to be in that account after 3 years. So how might we find the answer to that problem? One method would be just to use a step-by-step approach. So we could say, alright, after 1 year we're going to have our $100 plus 10% interest on that. 10% of $100 is $10, and if you take $100 plus $10, that's $110. Simple enough. Then, what about the second year? Well, you've got $110 at the beginning of the second year. If you earn 10% of that, then the interest earned in the second year is actually not $10, but it's $11. So if you take this plus $11, you'll end up with $121. And then if you start the third year with that, 10% of $121 is $12.10, and if you add that in, you end up with $133.10. Let's get an idea of what's going on here as far as the formulas. Okay, so let's look at it this way. What's the future value after 1 year? Well, I would argue that it's the present value that you started with plus the interest that you earn. Okay, I don't think anyone would argue with that. So how do you know how much interest you earn? Well, you calculate the interest as what you started with times the interest rate. Fair enough. Okay, now what I'd like to do is modify this formula just a little bit, not very much, but I'm going to change this initial PV over here to PV times 1. Alright? And now I have PV times 1 and I have PV times I. Well, we can factor out the PV, and that's just going to be PV times 1 plus I. I want you to be very familiar with that method, multiplying by 1 plus the interest rate. In this case, the interest rate was 10%. And in decimal form, that's going to be 0.1. So in this special case, let's see, that would have been an interest rate of 0.1. And so you could have written it this way: the present value times 1 plus 0.1. Now in reality, you should realize that that's just 1.10, and I want you to get to the point where you can do that conversion almost without thinking about it. So you know that if something is going to grow by 10%, then that's the same thing as multiplying it by 1.10. Along the same lines, if it had grown by 5%, then you would have just multiplied by 1.05. If it had grown by 20%, then you'd be multiplying by 1.2 or 1.20. Okay, but in this case it was actually 10%. Okay, so we've figured this out for our example. I want to go ahead at this point and change the formula back to 1 plus I. Alright, so we've got the future value after 1 period is just the present value times 1 plus I. Well, what would the future value after 2 periods be? Well, I would argue that it's the future value after 1 period times 1 plus I again. Why is that? Well, because you're taking what you had at the end of the first year and you're again growing it at an interest rate of I. And the effect of that is to multiply what you had by 1 plus I. In this case it would have been 1.10. But don't we already know what this is? Don't we already know what the future value after 1 period would be? We wrote it out up here. So we could just copy this and put it in here. So the future value after 2 periods could be thought of as the initial amount, the present value, times 1 plus I times 1 plus I. What about the future value after 3 periods? Well, that'd be the future value after 2 periods times 1 plus I. But again, we already know what the future value after 2 periods is. So we just substitute it in. Okay? Hopefully you see a pattern here. Hopefully you see that to find the future value after any number of years, we just take the initial amount, the present value, times 1 plus I times 1 plus I times 1 plus I, however many years we've got in there. Now of course we don't want to keep writing these 1 plus I factors out so many times, so a shortcut notation would be as follows. we could say that the future value after n years, however many years that may be, is going to be the present value times 1 plus I to the power of n. Of course, that exponent n just indicates the repeated multiplication that's going on. Okay, so this is a critically important formula. This is one that you absolutely must know. And in fact, you need to know it so well that you can use it and hardly even have to think about it. So if you need to start with an initial amount and it grows for n years at a rate of I per year, then you need to know immediately that you've just got to take that amount and multiply it by this factor, 1 plus I to the n. And in fact, we could have done that here. Let's go ahead and do this on a calculator really fast. I'll begin with a graphing calculator, and then I'll go to a TI BA2 Plus. Okay. For this particular problem, again, we're just applying the formula. It's just the present value times 1 plus I to the power of n. So very quickly, we just take the present value of $100 and then we multiply by the factor 1.1 to the power of, there's your exponentiation key right above the divide sign, it's a little caret, to the power of 3, and of course you get your $133.10, which we already knew was the correct answer. You can also do this on a TI BA2 Plus, but before you do, let's take care of a couple of calculator housekeeping issues. The TI BA2 Plus comes out of the box set by default to 2 decimal places. So that means every single calculation you ever do shows you 2 decimal places only. And that's fine if you're only looking at dollars and cents, but sometimes you are and sometimes you're not. So how do you get this thing to behave like a normal calculator? In other words, how do you get it to act like any other calculator? So if you type in 2 plus 2, then it would just say 4 instead of saying 4.00 like this does. Or if you type in something like the square root of 2, then instead of just getting 1.41, you could actually get it out to a whole lot more decimal places than that. Okay, it's really easy, but it's not obvious unless you look in the manual. So here's how you do it. Okay, first you're going to push the second key, and then you're going to push the format button, and then you'll see that the initial setting is 2 decimal places. We're going to change this to 9. Now, we're not always going to show 9 decimal places. Don't worry about that. But this is the special setting for what we call floating decimal point. In other words, to make the calculator act like a normal one. So you type in 9, and then very importantly, you press the enter button at the top of the calculator, and then that's taken care of. There's still one more housekeeping issue that I'd like to go ahead and take care of. Push your down arrow key 4 times. There's 1, 2, 3, 4, and we're going to change this mode here. Right now, the calculator doesn't know how to do the order of operations when it comes out of the box. Like the graphing calculator does. It knows to do the exponentiation first, and then do multiplication and division, and then finally do addition and subtraction. The BA2 Plus does not follow that sequence unless you tell it explicitly to do so. So we're going to change this setting so that it will do so. I'm going to push the second key, and then I'm going to push set, which is just above and to the right, and now it changes to AOS, which is algebraic operation sequence or something like that. And now we can get out of this by pressing the second key and then quit right above it. And now we're set. We can go ahead and work this problem. We can type it in as 100 times 1.1 1 to the power of, here's your exponentiation key, to the power of 3, and then push the equal sign, and of course we get the answer that we're supposed to get, which is $133.10. Okay, there is a calculator method for solving for this future value, but I'm not going to worry about that very much right now. We'll get to using the calculator shortcut buttons pretty soon anyway, but you shouldn't really need to use the calculator method for a problem this simple.